Imagine if we could shrink down, becoming so small that we plunge into a world beyond the reach of ordinary microscopes. Welcome to the hidden universe of atoms, the basic building blocks of everything that exists. From the screen you're looking at, to the air you're breathing, everything around us is made up of these minuscule particles. But atoms aren't just tiny. Inside each one, there's a world so vast it's almost incomprehensible. Picture a buzzing nucleus at the center, surrounded by a cloud of electrons whizzing around at breakneck speeds. But what's truly mind-boggling is the sheer amount of empty space within each atom. Despite the constant activity, the space between the nucleus and the electrons is vast, like a solar system in miniature. So, in reality, if you could see atoms, everything that appears solid is almost entirely empty space. Now, isn't that a thought to ponder? Now, consider an orchestra. Each musician plays a different instrument, just as each atom has different components that work together harmoniously. In the atomic orchestra, the star performers are the protons, neutrons, and electrons. Let's start with the protons. Protons are like the brass section of our orchestra. They're loud, they're powerful, and they give the orchestra, or in this case, the atom, its identity. The number of protons in an atom determines what element it is. For example, an atom with 1 proton is hydrogen, while an atom with 6 protons is carbon. Next up, we have the neutrons, the percussion section of our atomic orchestra. They provide stability, just like a steady drumbeat holds together a musical piece. Neutrons prevent the protons, which carry a positive charge, from repelling each other and blowing the atom apart. The number of neutrons can vary within atoms of the same element, creating different isotopes. The final section of our atomic orchestra is the electrons, the string section. They're light, they're fast, and they whiz around the nucleus in different energy levels or shells. Electrons give atoms their chemical personality. They're the ones that interact with other atoms to form bonds and create everything from water to DNA. And at the center of it all, like the conductor of the orchestra, is the nucleus. The nucleus, made up of protons and neutrons, holds everything together, keeping the electrons in check with its positive charge. The balance and harmony between these components determine the type of atom, its stability, and its ability to bond with other atoms. So the next time you look at the world around you, remember the atomic orchestra. The trees, the air, the water, even you are all made up of these tiny musicians playing together in perfect harmony. Just like in an orchestra, every component in an atom has a specific role to play, creating the symphony of matter that makes up our world. Atoms are not static. They are more like dancers, constantly in motion. Picture an elaborate ballet of particles eternally spinning, twirling, and interacting in an atomic waltz. This ceaseless dance of atoms is at the heart of all matter. Atoms don't exist in isolation. They are social entities, constantly forming and breaking bonds to create molecules. These atomic bonds are not mere handshakes. They are more akin to intricate dance steps, choreographed by the laws of physics. They form the structures of our world, from the simplest water molecule to the complex strands of DNA. The tempo of their dance dictates the state of matter. Slow, rhythmical movements result in solid structures, while faster, more energetic steps create liquids and gases. As these atoms dance, they interact, they bond, they break away, and they form anew, a dynamic ballet that never stops. The dance of atoms forms the rhythm of our universe, from the air we breathe to the stars in the sky. The world of atoms is fascinating and full of potential for discovery. Imagine this: each and every atom is a miniature universe waiting to be explored. When we dare to venture beyond the atom, we find a world rich in mystery and potential. Diving deeper into the realms of chemistry, physics, and quantum mechanics, we can uncover the secrets of matter, energy, and the universe itself. This understanding leads us to remarkable advancements in various fields. In technology, the manipulation of atoms has given us nanotech devices, revolutionizing our everyday lives. In medicine, atomic-level research has led to breakthroughs in drug development and diagnostic tools. And in environmental conservation, the study of atoms has opened up new ways to harness clean, sustainable energy. By delving deeper into the world of atoms, you embark on a journey of discovery that could change how you see the world and even how you interact with it.